Hey everybody, thanks for taking time. There was a little bit of confusion over the schedule, but I appreciate you. My name is Rick Bosworth. I am Director of Product Marketing. Now please don't run out the door. I am a marketer, but I'm not that kind of marketer. I'm a former technologist, product manager, developer back in the day. So containers are on fire. Everybody is using containers in either they're on-prem with OpenShift or public AWS, Azure, Google Cloud. And there are some misperceptions out there, not only about how to protect those containerized workloads, or even if they need containerized workload protection. The other thing is, raise your hand if you are exhausted by every cybersecurity vendor out there peppering your inbox saying that they're AI powered. I'm tired of it, all right? Let me begin. I empathize with you. Let me begin by saying SentinelOne was founded in 2013 on AI. We set out to disrupt the AI industry using the power, the cybersecurity industry using AI. So it is not new, it is not sexy, and it is frustrating that we have to push through this noise in an attempt to get our message out there. That said, let's protect your containerized workloads. I'm gonna blast through that. Okay, level setting, top 3 causes of cloud security incidents, probably no surprise to anyone here. Misconfigurations, compromised credentials, access keys, tokens, and then vulnerable web applications that are running on your cloud. So, I'm sorry, turn it down. Oh, okay. Exactly. So there are things that we're going to be talking about, how CNAPP, or Cloud Native Application Protection Platform, through things like practical use of AI, can help with this. And before we leave this slide, CVEs with known exploitation up 20% last year. I was really fascinated by the stat that the GM put up there this morning during the keynote with regards to, what was it, 250,000 CVEs? I mean, could I, show of hands, who is a developer? Okay, and who is on the security side? Okay, all right. All right, I like that, security and dev. So any developer worth their salt is now also in the boat with you in security. But to my security brethren, brothers and sisters, devs already have a full-time job. So throwing over the wall to them a register of CVEs isn't really helping them. What we want to do is use AI to help them understand what CVEs, what vulnerabilities are most important for them to solve. That's where AI has practical use.
We have a triage meeting every time.
I'm sorry, could you repeat that?
We have a triage, we have a triage meeting every time a CVE drops, and we either say, we gotta do this now, or there's no obvious path to exploit.
So for those that couldn't hear, every time a new CVE drops, they have a war room. They get together and they decide what needs fixing. Could I ask, what are the inputs into that decision?
Usually it's me and one other dev, hop in Google Meet, we read the CVE, we look at, details there, and we, quite frankly, make a value judgment.
Okay.
It's not as much sophistication as one might think, but
So it's better than nothing. 2 humans playing whack-a-mole and 2 humans with a real daytime job, but their daytime job also involves operating securely, but being overwhelmed by a tsunami of CVEs. That's what I mean by the whack-a-mole. All right.
to be fair, we only look at the CVEs the tooling that knows all the dependencies in the application build flag. We're not just, there's a CVE out there. It's
Great.
on your audit to identify the CVE in this code base.
Great.
How much severity is it?
Awesome. So we're going to be able to automate that process for you. The exploitability probability, what is actually deployed in production, what is deployed in production and is internet facing through automated attack path analysis. So the SOC is too unbalanced. You know, defenders are spread thin. We all know that. And attackers are persistent, they're focused, they're creative, and they're also using AI. Polymorphic ransomware is a thing. And they're increasingly sophisticated. We're less and less going up against script kiddies in their mother's basement, and more we're talking about nation-state attackers. Now, unfortunately, let me remove the word unfortunately and just say there are a lot of cloud security tools out there. The problem is they're all point specific. Instead of multifunction, they're single function. I'm a DSPM, I'm an ASPM, I'm a CSPM, I'm an XPM, whatever. All of these are collecting a metric ton of telemetry, and they're locking it away nice in one silo. And Dr. Schneier was up there talking about the advantage of having all the data co-located in one data lake. Why is that? So that the ghost in the machine, the AI models that you've built, you've trained, can chew on that data, suppress noise, and hand you insights. Imagine, if you will, the gentleman right here talking about their process. Imagine the ghost in the machine telling you, you need to have a remediation plan for this CV, this CV. You can ignore everything else in the news. These are the 2 CVs of the day. So this is the problem. They're noisy, they're disconnected, and they're often lacking that machine speed context. And I was pleased to hear Bruce also talk about how he said computer speed. Attackers with a single enter can run a fully automated shell script that will own your workloads in seconds. All right. So proposal, how to boost the cloud SOC's productivity. It begins not only with the autonomous reactive health, this would be the watcher on the wall, the agent-based CWPP or cloud workload protection, but also taking that context and tying that back to build time so that you can build clean and deploy clean as well as run clean. So that's that evidence-based proactive health actions that you can take. A very simplified view of what a CNAPP is, just to establish a common vernacular. So here we have the agile development loop. What we want to do is focus on the runtime visibility, the runtime threat detection. That's over here on the reactive side. And then shifting the focus over to the proactive side. That's where we can get into things like infrastructure as code scanning, secret scanning, vulnerability scanning, software composition analysis, SBOM. And I was also interested to hear Bruce mention this morning that, and I haven't had an opportunity to go get my book signed, but he mentioned that he would view something like secret scanning, examining the code for clear text secrets, or dare I say even encrypted secrets. He would call that AI. You know, I would just, maybe that's machine learning or just rule stuff, but I want to talk to him about that. I typically don't think of that as AI. It's not AI.
It's intrusion detection data is a sensor.
Right.
And there's extremely high truffle fog, for example.
Correct.
I have found it almost useless assessment because it flags on other range streams that are not in sequence. So it's
trust but verify.
High false positive rate.
Yeah. So cloud security from SentinelOne involves a combination of not only the cloud workload protection, but also the artifact scanning, looking at your golden image for your containerized workloads, for things like secrets. And we're also going to check your configurations, CSPM, KSPM, so that you can deploy clean. So left to right, well, I actually think this is a build. Build clean, release clean, run clean, and eventually when something runs off the rails, think Log4j, ruining everybody's Christmas 3 years ago, the runtime security in real time can detect that threat and squash that threat before the evil spreads. And we can talk a little bit more about that. Could you repeat? Running clean means that you're going to be operating smoothly without interruption from malware, threat actors, things like that.
Blank slate, like throw away all the cache state, build, or do you need testing blank clean?
So what I'm talking about is we've identified a runtime threat. We're going to go back to build time in the code, identify the exact vulnerability. The SecOps people are going to work with the developers and the AppSec and say, we're going to change this line of code, because ultimately the SecOps people, as you know, can't deploy. They don't own the fix. The developers do. We need to solve this for this reason. Let's rebuild the workload and deploy it cleanly to production, free of the vulnerability that we've already identified that was exploited. No, this is great. Okay. Let's talk about that then. I definitely want to synchronize my security speak with developer speak. So yeah, let's talk about that offline. Singularity Cloud Security is our comprehensive AI-powered CNAPP. It combines the rapid agentless insights as well as the stopping and forensic power of an agent at runtime. Gartner has a lot to say about what should go in the pretty boxes. Anything you see highlighted there in purple, SentinelOne covers. This isn't a product pitch, but I wanted to, and you might ask, well, what are you doing about the things that aren't covered? We partner. And we might also be building, but this isn't, you notice I did not begin with a safe harbor statement, so I'm not talking about what we might be building and when it will be available. Great stuff. All right. Cloud security overview consists of 3 things, hence the impossible triangle over here. It's just a snazzy little visualization to drive memory. So we have the real-time AI-powered cloud workload protection. That is the one in the middle, cloud workload security, has 5 detection engines on board, 3 of which are powered by AI. The other 2 are more rules-based. But this technology has been proven over the course of 11 years, has been tested against 1 billion malware samples. We'll talk a little bit more about AI learning in a couple slides. Cloud native security is our agentless CNAPP. Earlier this year, we acquired a company called PingSafe. You may have heard of it. That closed on February 1st. On the first week of May, we had fully integrated that agentless CNAPP in our Singularity platform. Singularity is the AI-powered platform by which we build and deliver every security solution from SentinelOne, fully integrated. And then cloud data security, you don't want your S3 buckets to become a forward operating base for the bad people to place malware. Why? Because malware can spread. The cloud is all about machine and human identities, and machine identities can really take this stuff and spread havoc, so you don't want that. Cloud workload security, we have 3 flavors. Really? It depends on you. Where are you running your workloads? Are you running your workloads on a server in your data center, on an Amazon EC2 instance or virtual machine, or are you running a containerized service up in Amazon EKS, Azure AKS, so on and so forth? We support 15 major Linux distributions, 20 years of Windows Server, major container runtimes, Containerd, Cryo, and Docker, so on and so forth. And most recently, earlier this year, we announced support for serverless containers. You might be running workloads on Amazon ECS Fargate. It's Fargate that makes it serverless. ECS is Elastic Container Service, and EKS is Elastic Kubernetes Service. So that is real-time threat detection and response. It's based upon eBPF, or the Extended Berkeley Packet Filter architecture. What this provides, the reason why you care here, is I like to call it God mode. No offense to anybody. It's just I see everything that's happening in the kernel. I record all the things, so I have observability without interference. So I'm going to observe the things, and when or if I have to intervene, the agent can intervene, shut down malicious process, surgically unwind. It's pretty cool. The other advantage of eBPF is that it is stable and scalable. What I mean by that is no kernel modules, and therefore no probability of kernel panic. We stay out of the kernel. And that message was true before July 19th. It's still true right now. And there you see the engines. The static AI engine is an ML engine. That is truly the workhorse of our detection technology. I think roughly 2 out of every 3 detections are the work product of the static AI. And when I say something has been trained on over 1 billion malware samples, that's really what I'm referring to. Behavioral AI is another one. If something gets past static AI, it is not getting past behavioral AI. But behavioral AI adds the dimension of time. If this step happens, followed by another, followed by this, eventually we can probabilistically analyze that sequence of events in the attack chain and said, this has eclipsed thresholds of normalcy. All right, this is now suspicious or even malicious. You might want to take a look. Or if you want to put the agent in protect mode, the AI-powered agent in protect mode, rather than just say detect, hey Rick, evil is happening. In protect mode, hey Rick, evil happened and I squashed it. We have some videos up on our website that are interesting. One's called Don't Blink. It's 1 minute long. It shows it happening. How do we protect your containerized workloads? Here we have a Kubernetes cluster. We deploy what we call a helper agent up here on the master, and then 1 agent per node in the cluster. That 1 agent not only protects the host of the worker node, but also every pod and every containerized service within the pod. So at production scale, where we're averaging, you might be averaging around 30 pods per node, it becomes ridiculously economically viable. Customers do the napkin math, and yeah, this is definitely something you don't want to miss out on. Again, the container runtimes, and I don't know why it's up there, but yeah, we support 64-bit architecture, including ARM for your CPU. Oh, it's deployed as a daemon set. So what a daemon set is, for those that might not know, is think of it as a ship's manifest. Every time the Kubernetes master says, hey, demand on my workload, maybe it's Black Friday and I'm running Target.com or Amazon.com. The master says, wow, this workload is running hot. We're consuming way too much CPU and memory on this worker node. I need to elastically expand my workload's capacity. I'm going to automatically spin up another node. What the master does when spinning up another node, then looks at the ship's manifest or the daemon set and says, I have to deploy this, that, the other thing, and the SentinelOne agent. So regardless of your workload scaling up and down, so does runtime protection. How does that change for serverless infrastructure like Amazon Fargate? Well, on Fargate, the whole point is it's serverless, so you, the customer, don't have to worry about the host. They do more, you do less. You do more innovation, you do less infrastructure management. Now, the cost there is you do less infrastructure management. Guess what? If I'm sharing a host, because ultimately there is a server behind this, there is a VM, there's an Amazon EC2 instance. If I'm sharing that EC2 instance with a person from every one of these tables, I cannot go install an agent. That's bad pool, that's bad tactics. But what we can do, and this is the only runtime agent in the SentinelOne portfolio that is architected this way, we can inject a sidecar agent. And all that means is we containerize the agent and we deploy it right alongside your containerized services that are running on that Fargate pod. Now, if you're running ECS on Fargate, it's called a task, but whatever, you get the idea. So it's a containerized agent at that point that runs in the pod. So unfortunately, we won't have visibility on this architecture of what's going on in the host, but we can feel vibrations that might be happening in the host by putting our hand on the table, so to speak. So that's runtime protection for servers, VMs, for containerized workloads running on self-managed or managed Kubernetes, as well as containerized workloads running on serverless infrastructure. Let's talk about the AI engines. Machines are exceptionally great at doing manual drudgery. Humans are really bad at it. They get burned out, they get skeptical, they make mistakes, they lose focus. Machines love this stuff. What machines are exceptionally bad at, thankfully, is what we're great at. Judgment, intuition, experience, applying that. So it's AI, it's not coming for your job. It's AI that's coming to help you do your job better. The static AI engine, as we were talking about earlier, inspects the file itself, pre-execution, looking for indicators of malicious intent. After looking at over 1 billion malware samples over the last decade, the machine models are very well trained. They tend to know what bad looks like. I mentioned that the static AI engine is the workhorse. It's responsible for about 66% of our threat detections. So the ML algorithms learn good from bad. We periodically make updates to the models available once per quarter. We do not force feed you a single update. It's up to you, the customer, to decide if you want to take it or you'll pass by and wait for the next train to come to the station next quarter. Behavioral AI adds the dimension of time. I mentioned earlier, and I think I stole my thunder here. Here we're looking at the attack chain, a sequence of events. If somebody goes to gzip a file or create a tar, that's not terribly interesting. But if it's zip after zip after zip within like 50 milliseconds, that suddenly starts to sound like it might be a ransomware attack. And that can cause a suspicious trigger on the behavioral AI. It also links the related events in that sequence. So when it comes time to respond, and there are two modes of operation, detect and protect. Protect automates the response action. We are not only deleting the atomic process that triggered the engine, we're actually surgically excising the entire tumor. From the point where the ghost in the machine works back and says, it all began with this parent process. Why is it doing that? So that you can get back to a known good state. That's all about the AI-powered runtime security. So it's real-time, AI-powered threat detection and response at runtime. Now let's switch over to looking at your cloud footprint from the outside in. And here we're going to be talking about the agentless CNAPP. I mentioned we acquired a company. It has a lot of features, including the one that I highlighted right here. So we commonly refer to the new acronym, that don't blame this marketing guy who created none of these acronyms, it's Gartner, KSPM, or Kubernetes Security Posture Management. Think of it like configuration security for your very promiscuous default configurations for your Kubernetes services. So we can automate the process of looking at this, identifying, hey, Laura, maybe you need to be worried about this configuration. I don't know if you were aware, you're not using a Kubernetes network policy in the way that you think you are. Just wanted to highlight that for you. So again, here the thing is agentless. So all you do is connect this service up to your cloud accounts or AWS organizations, and the ghost in the machine automatically, programmatically starts rate limiting API calls to your cloud accounts, gathering information, putting it in the UI here so that you can make informed action. But the one thing, and I want to make sure this isn't on the next slide. It is. So I wanted to talk about the offensive security engine. Any CNAPP worth its salt, any CNAPP, is going to have what I've visualized here. This is attack path analysis. This is table stakes. All right? It's like you are running a workload on a specific AWS EC2 instance that has that IP address with an open port 8081, and oh, by the way, it's running a workload that is vulnerable to that CVE. Automated analysis, any CNAPP can do that. What no other CNAPP has is an offensive security engine. So we're not only gonna show you this in Graph Explorer, and again, table stakes, anyone can do that. We're gonna automatically validate that exploit. We're gonna safely simulate an attacker. We're SentinelOne, we're the good guys. We're not gonna do any harm, we're not gonna own you, we're not gonna do anything. AWS will not let us do anything bad to you. But what we can do is just, if you left the door open, we can walk into your house, take a selfie, and then send you that selfie. Loosely, that's what's going on. What does that selfie do? It helps you, the SecOps person, share those artifacts of exploitability with the developers and say, look, this. And now imagine if I was a bad guy. I came into your house while you were sleeping and I found the silver and I took your grandmother's china and I put it on eBay. So that is the value of the offensive security engine. We're gonna automatically validate and present evidence of exploitability. What is the benefit to you? One, you're gonna collaborate better, SecOps, AppSec, and developers. You're also gonna prioritize better. You're gonna know what you should be working on first. Because when I show up and I look at the dashboard every morning, I might have 357 alerts. Where do I start? I'm already overwhelmed. But if I click on the offensive security engine, it will show me, oh, I found 31 artifacts. Start with 31. Now, 31 might sound overwhelming. It's a little overwhelming to me, but I'm just one person. I'm not alone. I have 4 other guys in the SOC that might be working with me. So the 5 of us, we can begin to burn this stuff down. I don't work in the SOC. Not anymore. Okay, so here's the example of what we did. It's probably too small for you to see, but what we did is Cloud Native Security, our agentless CNAPP, detected a server-side request forgery, what we did, vulnerability, and so what we did is we curled down to there and we did a git. And we did a git of the key dump, and it's shown right here, and that's the artifact that we share with you, the SecOps people, who are monitoring the agentless CNAPP, and then you can take those artifacts, share with the devs, get stuff done. And sure enough, there you see the secret access key in this example. We do much more than scanning for secrets. And again, the punchline here, focus on what matters. What we just showed you, we call this verified exploit paths. Again, remember that pretty picture I showed you? Every CNAPP out there can do that. We take it a step forward. We're gonna help you automate, we're gonna automate validation and help you prioritize better. So you might be able to identify runtime vulnerabilities, the result of malware and or misconfigurations. Now, interestingly, increasingly, we see misconfigurations as an artifact of attacks. So the bad guys and gals are going into your cloud environment, and once they've established persistence, they might misconfigure things. We're increasingly seeing that, but with cloud workload protection and the combination of the agentless CNAPP, which is cloud native security, you can come together, pivot back to your golden images, pivot back to your infrastructure as code templates, solve it back at the root, rebuild your application, deploy clean, and run clean. Problem solved. That's the way. This is the way for any Mandalorian fans out there. Solve it once and redeploy versus how many instances of this containerized workload would you have out in production? I don't know. You tell me. Is it tens? Is it hundreds? 1,000? I would rather fix it once and redeploy. It goes back to the whole cloud infrastructure thing. It's cattle, not pets. Those that you understand that, great. Those that don't, I don't want to explain it with a microphone on. Yeah, someone understood it. So the conclusion, by going this route, we're going to rebalance. We're going to make life better for the SOC. But ultimately, it's not only the SOC here that we're making life better for. We're making life better for AppSec and for the developers. And with that, I would be happy to take any questions that you may have. Yes, sir.
I work for a company that is a customer of SentinelOne.
Thank you.
EDR, not cloud.
Okay.
I've experienced personal pain points around the AI detection.
Okay.
So I learned some lessons about how
Uh-huh.
Perhaps follow up and see what SentinelOne has done in that space of
Yeah.
detecting bypass attempts or some dealing with holes there.
I would love to get you plugged in with our product architecture team as well as our threat researchers. They're going to be the ones that are going to be able to talk in depth about our anti-tamper, but you're not wrong. In fact, you're spot on. We've seen this, and we're not standing still. We continuously innovate, and yeah, we definitely don't want bad guys bypassing our stuff. And not everything is to be dismissed, but we see all the things that are posted by would-be security researchers out on the social media, and then we politely, privately reach out to them and work with them. And then usually what happens is they had made a wrong deployment. And so when they bypassed, that's like saying they drove your car, but they actually hadn't started the engine type thing. They hadn't turned it on, basically. It's misconfiguration. So, what other questions? Yes, sir, in the back.
Yeah, so these are a lot of use of AI, right?
User PI, oh, personal information, yeah.
So my question would be, the AI also learns, right?
Uh-huh.
As it's inspecting something on site, it's also learning. Is this learning specific to an organization that is using your product, or is it global?
Okay, so your data is your data. And I didn't even talk about our Purple AI product. So that's more a question around what Purple AI is doing, not the AI in our detection engines. The AI and detection engines are just looking for malware. They're not examining your PII, your IP, anything like that. For customers of Purple AI, that is a generative AI product that is learning. I can promise you that if you are a customer at that table, and then each one of these tables is a different customer, each instance of the AI stuff, the learning that happens, that's your learning. It's not shared with any of the other tables, any of the other customers, if you will. Yeah. Your data is your data. Yes, sir.
Your AI agent operating the company, say, the server type infrastructure as well. Like if I'm running proxy and I download the proxy and ship to the client,
Yep.
I could pull that file and then we can send it off to a scanner and get the answer back as whether that is a compliant file.
Okay, so what the endpoint, you're describing a laptop, for example?
I'm describing a service that, say a proxy service.
Okay.
The laptop is connected through the proxy.
Okay.
I'm assuming when you talk about something called on the laptop,
Agent on the laptop, right. There is no appliance that's required. The only thing we do deploy is an agent, resource efficient. It is tested every year in public benchmarks from MITRE ATT&CK. We routinely work out of the box, no configuration changes, no delayed. So whether it's an agent on your endpoint or an agent up on a cloud VM, virtual machine, Amazon EC2, Google Compute Engine, whether it's on a containerized workload, as we talked about, or a serverless infrastructure like Amazon Fargate, the agent is out there observing the kernel telemetry from the workload, recording and sending that up to the SentinelOne cloud where it's kept securely in your tenant. You, the customer, can then go up there, your security operations people can look and say, oh, that file looks interesting. SentinelOne quarantined it as malware. Yes, you can download it to a sandbox, explode it, conduct sandbox analysis. Absolutely. Long-winded answer to your question, but yeah. I promise to do better on the next answer. It just took me a while to get there. Any other questions? Hey, I really appreciate your time and attention. Thank you so much.